Okay, so hello everyone. My name is Kunal and I'm your mathematics tutor. And we are actually doing differential equation and today is our lecture number 5. So let me recap the things कि हमने अभी तक क्या-क्या cover कर चुके हैं. So we all know that about the order and the degrees of differential equation. Then we all know about how to form differential equation. Then we all know that how to find the solution of differential equation जो कि पहला मेथड था variable separable, and the second thing we actually deal with the types of the homogeneous equation and उसके सारे cases हमने देखे. किससे लिंक करके देखा था हमने? स्ट्रेट लाइन से लिंक करके देखा था homogeneous differential equation. So today we are gonna learn something new thing. तो आज की अपनी पहली जो टॉपिक है वो एक्चुअली पोलर कोऑर्डिनेट्स के बारे में. ओके एंड तो आज हम लोग क्या क्या पढ़ने वाले हैं. सो लेट मी टेल यू समथिंग. आज अपन कवर करने वाले हैं पोलर कोऑर्डिनेट एंड देन कवर करने वाले हैं लीनियर डिफरेंशियल इक्वेशन. ओके, सो लेट्स बिगिन द चैप्टर. सो द फर्स्ट थिंग इज if substitution is so now I'm dealing with the polar coordinate. So let me give the heading here so that we are doing actually polar coordinate. Okay, so let's begin. So the first case is let me write it here. If see these are first theory part, then we actually learn some implementation. So differential equation में पहला जो 4-5-6 लेक्चर होते हैं ना वो मेजरली बेस्ड ऑन theory part भी होता है. ठीक है, so you have to first know the all theory and then you have to implement and then you have to learn how to implement those theory in questions. So in polar coordinate, our case one is if substitution is x is equal to r cos theta, y is equal to r sin theta, then x square plus y square is equal to r square. We all know that because if we square and add this both equation, we will get this equation. And when we divide this equation 1 and 2, what we'll get? We'll get y by x is equal to tan theta. So this is the important thing that we have to note it, and we are gonna use this in next step. Okay, so let's and name them equation as third and this as equation fourth. So from equation third, if we differentiate equation third, so what we will get actually, differentiate, we will get 2x dx plus 2y dy is equal to 2r dr, है ना? And what if I differentiate the equation 4? So differentiating equation 4, we get x square. We are देखो मैं बस क्या कर रहा हूँ, मैं बस basic differentiation ही कर रहा हूँ ना. I'm nothing doing extra. There will be x dy minus y dx is equal to the differentiation of tan theta is x square theta d theta. Okay, so what I did here is I just differentiate the equation 3 and 4. So what we will get? We will get like 2x dx by differentiating the equation 2 plus 2y dy plus 2r dr. And when we differentiate this by quotient rule, actually you all know when you read the chapter differentiation. So when I differentiate this, we will get this. Now, here one thing we will get, we'll get x dx plus y dy is equal to r dr. So let me try to put in a one box, and the second thing we will get x dy minus y dx is equal to x square sec square d theta, right? So what is our x actually? X is nothing but r cos theta, right? So let me put it here. So it will be r square cos square theta sec square theta d theta. So both get cancelled and we will get r square d theta. So here we will get x dy minus y dx is equal to r square d theta. So you actually देखो हमें यहाँ पे ध्यान क्या रखनी है? If we using the substitution x is equal to r cos theta and y is equal to r sin theta, so we will get x dx plus y dy is equal to r dr, and x dy minus y dx is equal to r square d theta. So this thing we have to actually use. Now let's move on to the second case. So our case 2 is something, if substitution, if substitution is if sub x is equal to r tan theta, and okay, let me do it something here. X is equal to r sec theta, r sec theta, and y is equal to r tan theta. So we all know that by some basic trigonometric identities, ki sec square theta minus tan square theta is 1. So we are going to use it here. So when we do so, what we'll get? We'll get x square minus y square is equal to r square. This is our equation number 3rd. And the 4th equation will be when we do y by x, what we will get? Let's do it here. So we will get 1 by cos into sin by cos. 1 by cos, I mean cosec theta we will get. So y by x will be 1 by of cosec theta, which is also equal to the sin theta. Now, this is our equation number 4. So don't try to worry much and just try to differentiate the equation 3rd. So on differentiating the equation number 3rd, what we will get actually? We will get 2x dx minus 2y dy is equal to 2r dr. And here we will get x square y dx, है ना? या फिर कुछ भी कर सकते हो. It's totally depend on you. X dy minus y dx. And when we differentiate the sin theta, it will be what it will be. It will be nothing but cos theta. And it will be like x dy minus y dx. And what is our x square? X square nothing but r square sec square theta. Will be cos theta d theta. So what we will get? We will get x dy minus y dx is equal to r square sec theta d theta. And we try to put it in a one box. And from here, what we will get? We will get x dx minus y dy is equal to r dr. So you have to remember that if I substitute the x is equal to r cos theta and y is equal to r sin theta, so we will get x dx plus y dy is equal to r dr. And when we substitute x equal to r sec theta and y is equal to r tan theta, so we will get x dx minus y dy is equal to r dr. And when we take the opposite of that, so we'll get r square d theta, and in next thing we'll get r square sec theta d theta. Okay. So this is actually the polar coordinate thing, actually polar coordinate substitution. Okay, so these things we will cover up. Now let's, this is actually the theory part. So let me show you how to implement this in problem. So let's begin it by taking some examples. So our first example is something look like, we have to solve x dx plus y dy divided by root under x square plus y square is equal to y dx minus x dy divided by x square. Okay, so look at here, we have to solve this. So if I take x is equal to देखो x dx plus y dy हमें तभी मिलती है जब हम x की वैल्यू r cos theta सब्स्टिट्यूट करते हैं एंड y की वैल्यू r sin theta सब्स्टिट्यूट करते हैं. लुक एट हियर, है ना? वी गेट x dx plus y dy. लेकिन हमें x dx minus y dy कब मिलता है? जब x की वैल्यू हमने r sec theta रखनी है एंड y की वैल्यू r tan theta रखनी है. Then we will get x dy minus y dy. Let me correct it here. X dx minus y dy, है ना? So okay, let me erase it and write it in a clear way. So here will be like x dx minus y dy. So here we will get x dx plus y dy. So what the favorable substitution here? So favorable substitution is nothing but x is equal to r cos theta and y is equal to r sin theta. So this term will be nothing but r dr. है ना? When we substitute x is equal to r cos theta, y is equal to r sin theta, our x dx plus y dy term will be nothing but r dr. Are you favorable with that? No? Now, okay, let me take that. R dr and divided by r square, because x square plus y square is nothing but r. So there we will get r is equal to, what is the value of y dx minus x dy? So it will be nothing but minus r square d theta. Look at here. X dy, look at here. X dy minus y dx value is r square d theta. X dy. So there will be this negative sign. So what do we get? Minus r square d theta. Minus r square d theta. And what is the value of x square? So x square will be nothing but r square cos square theta. So this will get cancelled. This will get cancelled. We'll get dr is equal to minus of sec square theta d theta. And we have to just integrate both sides. Okay, so you will get the final answer as, look at here, what do we will get? R is equal to, we all know the integration of sec square theta will be nothing but minus of tan theta plus some constant. And now try to convert this, polar form into कार्टेशियन कोऑर्डिनेट, है ना? मतलब एक्स वाई के रूप में कन्वर्ट कर दो, कार्टेशियन कोऑर्डिनेट. Okay, are you understand what I'm trying to say? So there will be like root under x square plus y square is equal to, what will be the tan theta? देखो मैंने सब कुछ लिख रखा है यहाँ पे. So the tan theta is nothing but y by x. So let me write it here. So minus y by x and plus some constant here. So this is the actually solution of this differential equation. Okay, so if you want to write, let's write it. Root under x square plus y square minus y by x plus k is the gen solution of जो भी हमारे पास वो d था, है ना? So this is the final solution. Okay. So देखो अप्रोच क्या लगानी है कि मेरे पास क्वेश्चन में x dx plus y dy दिया हुआ है. So definitely we have to choose the favorable substitution as x is equal to r cos theta and y is equal to r sin theta. लेकिन अगर कहीं पे x dx minus y dy आ गया, then we have to take the x is equal to r sec theta and y is equal to r tan theta. So this is actually the thing that we have to catch on. Now let's take the another example. Example number 2. So it will be something like example 2, and the question is x dx plus y dy. Look at, okay, let me write first question, then I'm trying to tell you. X is equal to x dy minus y dx. Look at here. Again, here will be x dx plus y dy. So my suggestion is to pause the video and try to solve by its own and then watch the solution. Agar solve nahi hoti hai tab. So there will be the favorable substitution is nothing but x is equal to r cos theta and y is equal to r sin theta. So what we will get from here is the x dx plus y dy value will be nothing but r dr is equal to x value r cos theta, and we all know that the x dy minus y dx is nothing but r d theta, right? Look at here, r square d theta, right? Okay, I think I made some mistake here, r square d theta. And now this r got cancelled. We will get 1 by r square dr, and we have to integrate the cos theta d theta. Let's try to integrate both sides. What we will get? We will get minus 1 by r, and the integration of cos theta is nothing but sin theta and plus some gate constant. Right? Now what I have to do here is, we all know that r is nothing but minus 1 by root under x square plus y square, because we have to convert this polar form into Cartesian form. I have to write it here. Convert polar form into Cartesian form. कार्टेशियन फॉर्म, दैट मीन्स एक्स वाई। एंड देखो यहाँ पे क्या था, tan थीटा इज इक्वल टू था y by x. So what is the value of sin theta? So we have to find the value of the sin theta. So we all know that the y is equal to r sin theta, है ना? So we can get something like sin theta will be y by r. So let me try to write it here. Y by r uh, uh, sin theta is equal to y by r, and plus some, we get some constant, and when we divide it here, what we will get? We will get -1 minus y by root under x square, y square is equal to some constant. So this is the actually solution of our differential equation. So देखो अप्रोच बस सिंपल लगानी है कि अगर मेरे पास x dx plus y dy दिया हुआ है, so we have to substitute x equal to r cos theta, y is equal to r sin theta. अगर अगर x dx minus y dy दिया हुआ है, then we have to substitute x is equal to r sec theta, y is equal to r tan theta. अगर 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 और हमें फिर क्या करनी है, then we have to solve the differential equation by, जो हम लोग जैसे स्टेप को फॉलो करते जा रहे हैं, खुद ब खुद सब कुछ हो रहा. And in last, we have to convert those polar coordinate form into the Cartesian coordinate form, because our general solution will be in the form of x and y, because our differential equation is form of Cartesian coordinate, right? x and y के टर्म है ना, तो इसकी सॉल्यूशन को आप r थीटा के टर्म में नहीं दिखा सकते. तो पहले क्या करनी है कि आपने उसे कोऑर्डिनेट को सॉल्व करें, एंड देन यू विल गेट टू द कि x क्या है एंड y क्या है, by the help of again converting the polar coordinate into the Cartesian form. Okay, so let me take the last example, then we starting our today's new topic, which is linear differential equation. So this is example number 3. Let me write it here. So it is nothing but x dx. Oh, again there is x dx plus y dy. Okay, okay. And divided by, let me raise it and write it in a good handwriting. So there will be x dx plus y dy is equal to is divided by x dy minus y dx. X dy minus y dx is equal to root under 1 minus x square minus y square, and divided by x square plus y square. Look at here. You have to solve this problem. So what I'm going to do here is, what is the favorable substitution here? So the favorable substitution, look at here. There is the x dx plus y dy, right? X dx plus y dy. So what's our favorable? So our nothing but x is equal to r cos theta, and y is equal to r sin theta. And x is equal to r cos theta and y is equal to r sin theta. So here we will get x dx plus y dy is equal to r dr, and divided by x dy minus y dx is equal to r square d theta, and is equal to, there will be like 1 minus x square plus y square is equal to r square, and there will be x square plus y is equal to r square. So what we will get from here is, let me try to write it here, and then okay, so take the r common from here, so we'll get r dr by r square d theta is equal to root under 1 minus r square by r. So this whole r get cancelled, so we'll get dr by root under 1 minus r square is equal to d theta. Now let's integrate both sides. So what we'll get, what is the integration of 1 by root under a square minus x square? This is nothing but 1 by a sine inverse of x by a. And also there will be sine inverse of 1 by r is equal to theta plus some constant. So here we will get sine inverse of r actually. Sorry, I did some mistake. Sine inverse of x by a now. So our x is actually r is here. So r. So here we will get r is equal to sine of theta plus c. And now we all know that the r is nothing but x square plus y square. यहाँ पे मैं क्या कर रहा हूँ? I just converting. What I'm doing here, I just converting the polar coordinate, into the polar coordinate into Cartesian format. So x square plus y square is equal to sine theta plus c. And you can put here like theta is equal to tan inverse of y by x. So you can proceed on from here. Okay. So let's move on to the our today's new topic, which is actually linear differential equation. Okay. So let's start our new topic, which is actually this is हमने अभी तक क्या क्या मेथड पढ़ा है. हमने अभी तक मेथड पढ़ा है वेरिएबल सेपरेबल मेथड, जो 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 तभी लगता था जब क्या बोलते हैं ऑर्डर एंड डिग्री ऑफ द डिफरेंशियल इक्वेशन इज 1. And now we are talking about the linear differential equation, which is actually important. So let me write it here. A linear, this is actually method of finding solution. Linear differential equation. Okay. So let me try to explain it first. Actually, we also call this thing in sorted LD, linear differential equation. And so its definition is, let me write it here and then I'm going to explain you. So a differential equation is said to be linear if independent let me write it here, if independent variables and all its linear equation is said to be linear if dependent variables. So I'm gonna write its definition. So first मैं एक बार लिख लूँ, then I will gonna explain you क्या आखिर हो क्या रहा है यहाँ पे. A differential equation is said to be linear if dependent variable and all its differential equation and all its differential coefficient occurs in degree 1 only and never multiply. तो बेसिकली यहाँ पे भी एक केसेस है कि जो अपनी डिफरेंशियल इक्वेशन होनी चाहिए वो होनी चाहिए डिग्री 1 की. ठीक है, डिग्री 1 होनी चाहिए. ऑर्डर we can take any, but mostly the degree will be 1. So let me write it in the form. So the linear, I'm using the short format, which is LDE, means linear differential equation. So the LDE of first order, LDE of first order is इसकी form कैसी होती है? So let me write it here. So its form will be something look like. So its form will be something look like dy by dx plus p, there is a p of a function of x in into y and is equal to q as a function of x, where px and qx are function of. Okay, so now like how to solve this linear differential equation, right? So for solving such differential equation, now it's time to learn the method of solving linear differential equation. Okay, so for solving such differential equation, for solving such differential equations, we have to find an integrating factor. So now let me define the what is actually integrating factor is. So the integrating factor is actually represented by I dot f, and it is nothing but e to the power. You all are familiar with the e, right? It's the logarithmic base, natural log की base होती है. E to the power px dx, and where px is the coefficient of y here. So this is our the integrating factor, e to the power px dx. Now uh, now the solution of now the solution of differential equation is equal to now the solution of differential equation is equal to y into integrating factor is equal to q into integrating factor into dx. Okay, so this is the actually the solution of differential equation. So now let me try to elaborate you. So देखो, अगर मेरे पास लीनियर डिफरेंशियल इक्वेशन उसे बोलते हैं कि जब अगर कोई भी डिफरेंशियल इक्वेशन इस फॉर्मेट का दिया हुआ हो एंड लाइक मेथड ऑफ सॉल्विंग क्या है, इसमें सबसे पहले अपन निकालते हैं क्या निकालते हैं, इंटीग्रेटिंग फैक्टर. ओके, एंड इंटीग्रेटिंग फैक्टर निकालते हैं एंड देन वी एंड व्हाट इज द वे टू फाइंड द इंटीग्रेटिंग फैक्टर is nothing but e to the power px dx करते हैं, जहाँ पे e is the nothing but px is nothing but the coefficient of y here. Okay, so now what I have to do here is कि हमें ये करनी होती है and then whatever we get as the integrating factor, we just use that integrating factor in the solution of the differential equation. Okay, so y into integrating factor is equal to, yeah, this is actually the solution of linear differential equation, which is actually the y into integrating factor is equal to integration of q into if dx. Okay, so let's try to look into some example and then try to illustrate this. And then after taking an example, we will go through its proof as well. इसकी proof कैसे होती है, so वो भी कर देंगे. But first try to understand कि आखिर ये सब integrating factor वगैरह है क्या. तो एक example लेके करते हैं, उससे सारी चीजें clear हो जाएंगी. So let me take an example here, because यहाँ पे कुछ नए term introduce हुए हैं, like integrating factor हो गया एंड क्या क्या हो रही चीजें समझने में दिक्कत है. सो इट विल बी, मैं इसकी प्रूफ भी कर दूंगा कि ये आखिर इसकी सॉल्यूशन क्यों है, कैसे है. सो फर्स्ट यू हैव टू जस्ट फोकस ऑन कि कैसे यूज करते हैं. सो लेट्स टेक द एग्जांपल इज समथिंग dy by dx plus y is equal to e to the power minus x. Okay, so now look at here, try to compare this equation to dy by dx px into y is equal to qx. So what we will get here, the px will be nothing but x to the power 0, because there is nothing but 1 only, right? So it will be px, and the qx is nothing but e to the power minus of x. So let's try to write it here something. So now let's try to find the first integrating factor, which is nothing but e to the power px dx. So what is px? It is actually x to the power 0. Actually, it is 1. So e to the power 1 dx. So it is nothing but e to the power x. Now the solution of our differential equation LDE is actually equal to y into integrating factor is equal to integration of qx into integrating factor dx. Okay, so y into, what is our integrating factor we get? We get e to the power x. So y into e to the power x is equal to the qx is, so we actually get from comparison e to the power minus x. So e to the power minus x and e to the power plus x dx. So it will be get cancelled obviously. So y to the power x, and there will be get x plus some constant. So this is actually the solution of our given LDE. But there is a lots of confusion is in your mind. I hope it is, because आपने ठीक है, ये मैं फॉर्म ऑफ लीनियर डिफरेंशियल इक्वेशन होती है, ये मुझे समझना आ गया, dy by dx इस फॉर्म का होता है, डिग्री 1 होती है. बट इंटीग्रेटिंग फैक्टर भी समझ में आ गया होगा कि ये कुछ इस तरीके से डिफाइंड होता है. ये एक टर्म है बेसिकली, इंटीग्रेटिंग फैक्टर इज बेसिकली अ टर्म, ठीक है, इंटीग्रेटिंग फैक्टर इज नथिंग बट अ टर्म, ठीक है। तो ई टू द पावर पी एक्स इसमें डिफाइन होता है, वो आपको निकालना होगा कि कैसे हो रहा नहीं हो रहा, एंड ये टर्म है। एंड the next thing is we have to do is कि the solution of differential equation, तो the solution of differential equation is कि ये कहाँ से आया, क्वेश्चन अभी भी मन में आ रहा है कि आखिर ये y into इंटीग्रेटिंग फैक्टर, एक तो इंटीग्रेटिंग फैक्टर समझ में आ गया ना कि ये एक टर्म है, ये बेसिकली एक टर्म है जब e टू द पावर पी एक्स डी एक्स की इंटीग्रेशन के इक्वल होती है, बट यू हैव टू थिंक दैट कि आखिर इसकी सोल्यूशन आई कहाँ से, y into integrating factor into q something like ऐसा। so let's try to prove it। पहले implementation समझ में आ गया कैसे implement करते हैं, first try to compare with this equation, get the value of px qx and then try to get the integrating factor and just write in the solution of differential equation। so let's try to prove the what we have to prove। so prove is something the solution of dy by dx plus pxy is equal to qx is equal to q as a function of x uh, is nothing but y into integrating factor is equal to integration of integrating factor into qx into dx। आई थिंक यही होती है, आप सभी ने समझ में आया होगा। सो लेट्स ट्राई टू प्रूव इट कि ऐसा क्यों होता है, क्योंकि हमने यही यूज करा ना, दिस इज द जनरल इक्वेशन ऑफ लीनियर डिफरेंशियल इक्वेशन। देखो हमने यही तो लिखा है ना, y इंटू इंटीग्रेटिंग फैक्टर इंटू इज इक्वल टू इंटीग्रेशन ऑफ q इंटू इंटीग्रेटिंग फैक्टर इंटू dx। नाउ लेट्स look at its proof। so it will be something like dy by dx plus py let me I'm just writing p as a function of x and p, so try to understand that p is a function of x and is equal to q। so what I'm gonna do is multiply both sides by if, which is actually what e to the power p dx। okay, so when we do so, so what we'll get dy by dx e to the power integration of p dx and plus py e to the power integration of p dx is equal to q into e to the power p dx dot dx। okay, and let me raise it from here। I just multiply both sides by, this is actually dy। now integrate both sides, integrate both side। so actually what we will get when we integrate both side, so हमें क्या मिलेगा बताओ, let's try to think on कि हमें मिलेगा क्या। so we will get the integration of d of y e to the power integration of p dx, right, and it is actually equal to integration of q dot e to the power p dx है ना। so it will be nothing but y into e to the power p dx is equal to integration of q dot e to the power p dx, and we all know that the e to the power p dx is nothing but our integrating factor। so y into integrating factor is equal to q into e to the power p dx, इसको integrating factor लिख देते हैं ना, so that will be easy for us as well। so let me write it here, there will be the if and into dx। so this is our in general equation, right, and now there is a इसी की मतलब सब पार्ट है कि यहाँ पे जैसे यहाँ पे तो हमने प्रूव क्या करा कि अगर dy by dx था एंड p एज अ फंक्शन ऑफ x था, तो इसकी सॉल्यूशन ये आ गई। बट इफ दिस इज अनदर सब केस कह सकते हो इट इज एक्चुअली अ सब केस जो ऐसा है कि इफ our LD is something like dx by dy this time and plus p as a function of y into x is equal to q as a function of y. अभी तक हमने क्या देखा था dy by dx था हमारा differential equation plus px plus y into qx का फंक्शन था. Now I am just doing I just replace x by y. x की जगह पे y हो गया, y की जगह पे x हो गया. So what will get dx by dy प्लस पी वाई पी एज अ फंक्शन ऑफ वाई इंटू एक्स. तो इसके सोल्यूशन में भी क्या होगी, बस कुछ नहीं होगा, बस एक्स की जगह पे वाई आ जाएगा एंड वाई की जगह पे एक्स आ जाएगा. तो द सोल्यूशन ऑफ डिफरेंशियल इक्वेशन इज नथिंग बट व्हाट इट इज. द सोल्यूशन ऑफ डिफरेंशियल इक्वेशन इज एक्स इंटू इंटीग्रेटिंग फैक्टर is equal to integration of qy into if into dy. So this is the, let me write it in a clear way. So, okay, so this is the solution. Okay, so I hope you all understand is what I'm trying to say. तो आज के पार्ट्स आपको समझ में आ रहे होंगे कि क्या चीजें हो रही नहीं हो रही. ओके सो हमने सारे केसेस देख लिए, लीनियर डिफरेंशियल इक्वेशन के सारे थ्योरी पार्ट हमने कवर कर लिए, कहते किसको है, कैसा फॉर्म होता है, उसकी क्या, उसकी मेथड क्या है, उसकी सॉल्यूशन को गेट करने का, उसका सॉल्यूशन आता क्या है, एंड ठीक है. एंड नाउ इट्स टाइम टू implement those things into some problem. So let's start with the basic problem and then we will move to the next part. So our problem is something look like example number 1. It is something like dy by dx plus 2 into y by x is equal to x into ln of x. Okay. So you have to find. So my suggestion is to pause the video and try to solve it by own because मैं पहले भी करा चुका हूँ. यहाँ पे तो मैंने बस प्रूव करी कि हाँ इसकी सॉल्यूशन ये होती है. देखो मैंने लिख दिया यहाँ पे कि इसकी सॉल्यूशन ये होती है, बट ये तो टर्म डिफाइंड है. इंटीग्रेटिंग फैक्टर्स ये तो टर्म डिफाइंड है कि ये यही होता है e to the power px. इसको हमने डिफाइंड करा है. But how we know that the solution of the linear differential equation will be y into integrating factor is equal to integration of the qx function into integrating factor? How will we know that? So मैंने वो prove करा है and just we are multiplying both sides. तो एक बारी proof देख लेना आप, ठीक है. So I'm not going to in the proving section now. I'm just gonna to tell you something like how to implement those theory concept in practice. So let's try to begin. So there will be dy by dx is equal to 2 into y by x. So let's try to, first thing is that what we have to do in solution, compare the given differential equation to dy by dx. क्योंकि देखो dy by dx क्या है ना, तो उसी से कंपेरिजन कर लेते हैं. So px into y is equal to q as a function of x. So there will be what we will get px is equal to 2 by x, qx is equal to x into ln of x. So there will be first, now next thing we have to find the integrating fraction, right? So what is the actually the integrating factor is? So integrating factor is e to the power pxt. So let me try to find it here. So it will be like e to the power, the px will be 2 by x dx. What is the integration of 1 by x? It will be nothing but 2 of ln of x. That means we can write into e to the power ln of x square. Now, you all know that this property, the basic property of logarithm is e to the power ln e something, and there will be, so this and this base will be same, so it will be automatically at x square. So our integrating factor is nothing but x square. Now let's move on to the solution of our differential equation. देखो पहले ये करना होगा, स्टेप्स यही हैं सारे. कंपेयर करके पहले px एंड qx निकाल लो, देन इंटीग्रेटिंग फैक्टर निकालो, है ना. देन क्या निकालो, इंटीग्रेटिंग फैक्टर निकालो, एंड the solution of differential equation is nothing but y into integrating factor is equal to integration of x, q is a function of x into integrating factor into dx. So what is our integrating factor, which is like x square is equal to, we have to integrate. What is our qx? So qx is nothing but x of ln x. So x of ln x and what is our integrating factor, which is x square. So there will be x q and dx. So you all know that, right? You have to apply the by parts. So because here we have to, देखो यहाँ पर क्या हो रहा है ना कि जो हमने इंडेफिनेट इंटीग्रेशन में जो पढ़ा था कॉन्सेप्ट, जो भी कॉन्सेप्ट हमने पढ़ रखी है कि हाउ टू find the integration by parts, so it will be applying the Eilert rule, right? So when we apply the Eilert rule, so our u will be nothing but logarithmic function. So this is our u and this is our v. And just try to, on integrating, what we will get? We will get x square. Let me write it here in a clear way. So here we will get x square y. X square y is equal to x to the power 4 by 4 log of x minus x to the power 4 by 16 plus some constant. I hope you'll all know that how I solve this. I just using the concept of Eilert. You all know now by parts. So I just use the by parts here. Let me write. I use by parts. अगर आपको by parts समझने में दिक्कत आ रही है, then just go to the lecture number 4 or 5 of indefinite integral part. मैं वहाँ पे cover कर चुका हूँ, so it will be easy for you. Okay, because I am using here the indefinite integration by part rule. Let's check the one more example. The example number, this time of something different kind, right? This time we have to take like dx by dy kind. Okay, hopefully not get the such kind of problem, but okay, stuck with the dy by dx thing. Okay, so dy by dx, x into dy by dx plus y is equal to x. So now what you have to do, first thing, this is our differential equation. So now compare it to dy by dx plus pxy is equal to 2x. Okay, so now, so what we will get from here? First, यहाँ पे देखो dy by dx की एक coefficient x दे रखी है, so you have to nothing to worry about. इसको ऐसा लिख देते हैं ना, dy by dx and just divide it by x. So we'll get 1 by x into y is equal to x squared. We can right now. So here we'll get px is equal to 1 by x and the qx is equal to x squared. Now the third step is to find the integrating factor, which is like e to the power px dx. So we'll all know that we will get e to the power integration of 1 by x dx. So it will be ln of x, so we'll get the value of x. Now get to the solution of the differential equation. The solution of differential equation is nothing but y into integrating factor equal to integration of qx into integrating factor into dx. So what is our y? So our y is nothing but our integrating factor is nothing but x, and our qx is nothing but x square, and our integrating factor is x dx. It will be like xy is equal to, when we integrate this, it will be like x to the power 4 by 4 plus some. So this is actually the solution of the differential equation. Okay, so okay, that's all for today. So आज हमने दो topic cover करी, which is actually the polar coordinate system, and the second one is linear differential equation, which is actually important. अभी ये सारे देखो मैं level 0 का question दिया हूँ अभी तक. These all are like, मैं भी बस बता रहा था कि कैसे implement करनी है. Okay, so that's all for today. Thank you.